Right, hi, good day everyone. Today we are going to do the summary breakdown of paper 2, number 3 question. Now the topic that is being taught in these questions are your trigonometry, geometric and trigonometric topics, right? Some of these include types of angles, interior and exterior angles. Then we have SOHCAHTOA, and then there's Pythagoras theorem, which is something I did not add in. Um, Hi, good day, Root. Right, Pythagoras theorem. Then there is bisecting an angle. Then there is types of transformation, reflection, rotation, translation, and enlargement. But nothing too difficult, right? So the first thing that we're going to do is sum of interior angles. The formula for sum of interior angles is 180 multiplied by n minus 1, where n is equal to your number of sides. So how much ever sides that angle, that shape has, the polygon has, that will tell you what n is number of sides. Right, and the sum of exterior angles is always 360 no matter what it is. Yeah. Um so that was when we were doing interior and exterior angles. SOHCAHTOA, very quickly, I'm just gonna show you guys um what this is. So when we're using Pythagoras theorem or SOHCAHTOA, it is a right angle triangle that we're using. And in a right angle triangle, we know that it is denoted by a little box at the corner here. And the side that is opposite this 90 degrees angle, what is going on? Right. Opposite this is always your hypotenuse. Right, so if I list this A, B, and C, common B is known as my hypotenuse. This is common A and common B. Right, we know for Pythagoras theorem, it would be b squared, which is your hypotenuse squared, is the sum of your other two sides squared. Hold on, this is C, sorry, common C. This would be a squared plus c squared. And if you're trying to find b, it would be the square root of a squared plus c squared. Now, if they give you, let's say, one side and you're trying to, they give you a side and your hypotenuse, you want to find a squared would be b squared minus c squared, where a is equals to the square root of your hypotenuse squared minus one side squared. And that is how you would find out this. Now, for SOHCAHTOA, which we should know how to do, right? For SOHCAHTOA, they would give you an angle. Let's say this is theta, right? B is my hypotenuse. If it is angle C, then side C would be my opposite. It is the side opposite the angle that they give you, not your 90 degrees, right? And then the remainder, which is A, is your adjacent. Or if you want, your adjacent is the one that has both 90 degrees and the angle on one side. Do we understand this, guys? How to obtain or how you would recognize these things? Now, depending on what the question gives you is when you'll use SOHCAHTOA. If they give you hypotenuse and you're trying to find opposite, then you know it's sine. So it just depends on the question and what is given. Yeah, and that is Pythagoras theorem and SOHCAHTOA. Right? The only thing I would tell you is make sure that your calculator is in DEG. Right? Your cal is in DEG. Right? So this acronym tells you sine theta is OH, which is opposite over hypotenuse. Then cos theta is adjacent over hypotenuse. Then tan theta is equals to opposite over adjacent. Right, and that would be how you would do um remember how to do SOHCAHTOA. Right, next one, types of transformation. Now, in your types of transformation, Uh, okay, so in CSEC, there are four types of transformations that we have to take into consideration. The first one is this: reflection, rotation, translation, and enlargement. And I showed a letter B, reflection, along what you call this thing, along a mirror line. You see that the image is inverted, the object is inverted. Rotation means that along a certain point it would be rotated. Translation or slide, don't use the word slide, use the word translation, meaning it's either going up or down or left or right, right? Vertically or horizontally. It cannot move diagonally, right? Enlargement, as the name suggests, is it's getting bigger, or it's a dilation, it's getting smaller, right? Now, when you are doing reflection, now the most important thing that they would ask you to do is describe the transformation. Right? The first thing that you have to do with reflection, what you need is a ruler, and what you would need to describe it as the equation of your line. Right? Then, and with past papers, you'll see me doing this. Rotation, you'll need a ruler and a ruler and compass, or no, a ruler and protractor and compass, I should say. Right? And you need to locate the center of rotation, which is a coordinate, the direction of rotation, whether it is clockwise or anti-clockwise, and the degree of rotation, that is you're using a protractor to measure how much it rotated. Right? Then there is your translational slide. We talked about this. We have direction. You need to know the direction a slide occurs and the number of units a slide occurred. There are two properties. It is a displacement along your x-axis and a displacement along your y-axis. If you say that my translation and you tell them that this is your column vector, they will know that on top it displays so much units to whether it's positive or negative. If it's negative, then you went to the left. If it's positive, it went to the right. So it just depends, right? Um, oh, look, I have the note here. Right? The value of x is positive, the translation moves to the right hand side of the x-axis. If the value of the x is negative, the translation moves to the left hand side of the x-axis. If it goes up, then it is positive. If on your y-axis is negative, it goes down. Right? And then we have enlargement, which is the first thing you need to know is your scale factor. Scale factor is your image divided by your object, and the center of enlargement. I will teach you guys how to get that. Right? So these are the things that you really need to know. Now there are one or two things that you'll need to know, but this is the most important things that you need to learn to do number 3. So let's look at the first question here, and let me zoom up. This is January 2025. Right, so let's start. January, the diagram below shows a regular hexagon. Hexagon just means it's a six-sided shape, right? LMNOPQ. Whose side is each? So each is, when they say regular polygon, it means all sides of that polygon is the same. So this is 8, 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 and this is 8. Show that the value of angle PQL, so that's this angle here, is 120. Now, if it's a regular polygon, that means all interior angles are equal. The first thing you need to know is the sum of interior angles. And we know that the sum of interior angles is 180 by n minus 1. N minus 2, sorry, it's n minus 2. Did I put n minus 1? It is n minus 2, right? Not 1, guys. That is my mistake, is n minus 2. So let's do this one. The sum of interior angles, let's zoom in. would be how many? This is a six-sided shape, so n is going to be 6. This would be 180 by 6 minus 2, which is 180 by 4. And 180 multiplied by 4 is what, guys? 180 multiplied by 4 is 720. Now, if 6 sides or 6 equal angles, because it's a regular polygon. Remember, the side of the angle corresponds with the size of the angle. If all sides are equal, then all angles are equal. So if 6 angles is equal to 720, then we want to find for one of them, one angle slash PQL would be 720 divided by 6, which is 120 degrees. And that is how you would show that the value of PQL is 120. Now they said in this question the vertices, which is where they touch, two or more lines touch, right, or intersect, um, W, X, Y, Z, touch sides P, Q, Q, L, M, N, and O of the hexagon in part E. Right? They tell you that Y, Z, no, ZY is and WX are parallel, and LM and PO is parallel. Calculate the angle, the value of the angle LWX. LWX, so they want this angle right here. First off, let's talk about what we know, right? We know that this here is 120. We also know that this here is 120. This here would be 120. No, this here is 90. This here is 90. This here is 120. This here is 120. This here is 90. This here is 90. And this here is 120. This is what we know thus far. They said calculate the value of LWX. So they want to know this angle right here. Now I'm seeing two ways that we can do this. Right? There are two parallel lines. Oh, okay. Immediately I was like, what is going on? How am I going to find this? If you look at that, there are two parallel lines, and there's a line that is intersecting here, and they tell you that this here is 120. What would this angle be? We know that these two angles here are supplementary because they are interior angles. Are we seeing that, guys? So that means that 120 plus LWX, angle LWX would be 180. So LWX would be 180 minus 120, which is equals to, hold on, yeah, 120 minus 180, which would be 60. And that would be your answer for this question. Do we understand this, guys? Oh, those are supplementary. Let's look at this question here. Okay. In the following part, show all the construction lines where required. The field of a sports club is in the shape of a quadrilateral, which just means a four-sided shape, RSTU. A scale diagram of the field is shown below. Right? So now we're going to look at a lamppost is to be erected on the field marked point L, so floodlights can be installed. The point L should be located in such a way that L lies on a perpendicular bisector of UR and an angle LSC equals to 30. Using a compass and ruler only, locate the point L on the field. Now, first off, how do you find what is a perpendicular bisector? A perpendicular bisector is a line that intersects another line to divide that line into half, right? And also it intersects at 90 degrees. So when they say they want the perpendicular bisector of UR, right? Hold on. Now they told you not to use they said using a ruler and compass only. So UR. So what I am going to do is I'm going to show you how to do your perpendicular bisector using your compass. Right? So this is what you're going to do. This is your compass, and one of the things that you, whenever you're doing drawing angles or anything, is you just make sure it is open more than half the line. So I am going to draw more than half this line. So I'm going to draw, and they want to see these lines. You could probably um, neaten it up a little bit just for your sake, but I'm going to draw so we can see it. Yeah. Right, and then you take that same point and go to the next side. Make sure that you do not interfere with that length that you open up your compass, right? And then let's just intersect here. Right, this intersected here, and this one would intersect right here. Okay, I'm gonna erase all that other unnecessary lineage just to make my life a little bit better. We know that if I were to draw a line that connect these two lines, so I'm connecting this point here. Let's draw a red line. This line here intersecting this line here. This is my perpendicular bisector. Yeah? Do we understand that so far? How to find the perpendicular bisector? You open your protractor more than half the line, you put it on one side and draw an arc on top and bottom, and you do the same thing for the next side, and where those two intersect you draw a line connecting the intersection between the two arcs on top and the bottom, and that would be a perpendicular bisector. So this is intersecting at 90 degrees, and you can use a protractor to check and see to make sure it's correct, but this is how it is. Right, so let's read what they said. They said that point L is located somewhere along that line, right? And LST equals to 30. So LST. So um hi good Nakia. Hi good day Nakia. Right. So LST. So these are my two sides, and I want to find angle L here. Angle L is somewhere along this line here. Alright? So ST is your baseline, and I'm going to determine a 30 degrees. So first off, again, always make sure that your protractors, I'm going to do this in blue so you guys could see the difference. Always make sure that your protractor is open to make sure that it is more than half that line. Right? You're looking at line ST. Right? So you're going to put it here. Hold on, I'm just going to make this a little bit smaller. Right, put it at T. I'm just going to switch it around to make sure. Yes. So I am going to first draw an arc. Alright, and then from this line L, S, T. So then we're going to put this here, and then you're going to draw an arc intersecting that initial line, that initial arc. right? Then you're gonna take one and put it here where it intersected, and then you're going to draw an next arc, same point where it started here, and you're drawing a next arc, and you want them to intersect. So my 30 degrees is going to be somewhere here. Hold on, no, this is incorrect. Okay, let's just look at this again. They said point L is on your perpendicular bisector, which is this red line here. And then they said that angle LST is 30. So at S, you are making a 30 degrees angle, right? Because it's LST. So now, first things first, to make it 30 degrees, you put your the pointy part of your protractor, not your protractor, your compass, on S, right? Because that is your that's where your angle is going to be at. Alright. Hold on, someone is trying to join. Hi, good day, Alike. Okay, so it's at S, and then we are going to draw a 30 degrees angle. The first thing you're going to do is draw an arc. Right? Doesn't matter how big the arc is, just make sure it's more than ST. Alright? Right, and then you're going to take the end of that where it intersected this line, and you're going to draw a next arc. Now, by doing this, an arc that intersects that first arc that you drew, by doing this, that is a 60 degrees angle. That is how you draw 60. Right? Then you put where that 60 degrees is at. Again, all this time you are not changing how big you open your thing, right? And you're going to draw an arc here, and then here you want it to intersect that arc that you drew. So we know that from here to S is going to be 30. So let's do that back one more time. I want my angle at S, so I put my pointy part on S, and I draw. The only thing that you have to make sure is that it is more than half that line of ST, right? Then you draw an arc, one arc. Then you take your next pointy part and put where it intersected ST. You put your pointy part and draw a next arc that intersects that first arc you drew. That is 60 degrees. And then on where that intersected, you're going to put the pointy part and draw an arc at the outer part. And you do the same thing with this. Do you remember your pointy part had to go here? So what you're going to basically do is you are bisecting your 60 degrees. So this here was 60. So what I like to do is I like to place, or not like, how to make a, when you want to bisect an angle that we know already, you take your pointy part and put it at the two ends. So you put it at the end here, you draw an arc, you put it at the end here, you draw a next arc. This will divide that 60, and the half of 60 is 30 degrees. So I know that L is going to be located, because they said LST. So I know that L is going to be located where it intersects that red line, which is your perpendicular bisector. So L is going to be here. So from here to here, undo that, from where it intersected to S, that is 30 degrees. Now they told you L, or the lamppost, point L. Yeah, the lamppost marked at L is where these two were 30 degrees, LST, and that perpendicular line intersect. So L is going to be found where the perpendicular bisector and your 30 degrees intersect. So this here is going to be L. Let's put that in black So where the two lines here intersect is going to be L. Right? And that is how you would locate where your lamppost is going to be located. Right? So if you were to measure LST, this angle here is 30 degrees. This is your perpendicular bisector. So you know that angle L is located on your perpendicular bisector, and point LST is 30 degrees. So you know L is going to be located right here. And that is how you would do this question. Alright, so now we are going to go on to the next question here. Alright, that is it for number 3. So the hardest part in this, well, I think that the most difficult part was part B, which was 5 marks. And you do need to show all these arcs and stuff, because they did say using a ruler and compass only locate point L. So they are looking for those lines where your perpendicular bisector is and where your 30 degrees is at. They are looking for that. Yeah? Number 3, a vertical flagpole FP stands on a horizontal ground and is held up by 2 ropes. We have the 2 ropes here as shown. They told you PG is 18, FR is 9.7, and angle FGP is 38. Then they said calculate the height of the flagpole. Now, what I would do is I would look to see what type of triangle am I seeing here, guys? That is part of the flagpole. Very good, a right angle. Now, what is 18? Very good. And we want to find the height. We know the angle is 38, so theta is 38. Your hypotenuse is 18, and you want to find what? What is FP? Anybody can tell me? My opposite. Very good. So FP, which is equals to my opposite. So immediately I will write Toa. And which one would I use? Would I use sine, cosine, or tan? Which one has opposite and hypotenuse? Sine, right? So not this and not this. I would have sine theta is opposite over hypotenuse, which is sine 38 is equal to FP over 18. Again, when you're doing this, you need to make sure that your calculator is in DEG. If it is not, you will get a wrong answer. So make sure your calculator is in DEG. Okay? When you put this in your calculator, well, if I carry across divide, I'll turn 18 sine 38 is equals to FP. 18 sine 38 is equal to, so FP would be equals to 11.0819056 meters. But again, CSEC is the standard is 1 decimal place, so it'll be 11.1 meters to 1 decimal place. Alright, and that is your answer for this one. Does everyone understand this question? So now I know that this here is 11.1. Right? This is a 90 degrees. Find PR. What is PR, guys? If I'm looking at this triangle here, what is PR? My what? So there are two triangles. Go ahead. That's your hypotenuse. So you will get, again, you would not use SOHCAHTOA because we don't know any angles here. However, we know something called Pythagoras theorem, which is my hypotenuse squared, which is PR squared, is equals to the sum of my two sides squared. So 11.1 squared plus 9.7 squared. If I want to find PR, PR, hold on, PR is going to be the square root, because if I carry across the square, open bracket 11, if I carry across square, the opposite of squared is square root, right? 11.1 squared plus 9.7 squared, close bracket. Exactly how I have it here is what you're going to put in your calculator. The square root of open bracket 11.1 squared plus 9.7 squared, close bracket, and you're going to get 14.7. So PR is going to be 14.74109901, which is PR is equals to 14.7 meters to 1 decimal place, and that is your answer. And this is an easy 2 marks. Do you guys think that you could have done these 2 questions by yourself? Or anybody be like, no, miss, this would have given me too much of trouble. Anybody, everyone understands this? Okay, great. Let's go on to this one. So, if we look at this is your angles type question. Oh, okay. Alright, let's look at this question. In the diagram below, PQ is parallel to MR, LRT, where's L? RT is 28. LRT is an isosceles triangle. So they're telling you this side here and this side here is equal. Right? And STL is a straight line. Right, find the value of x. So, the first thing I would have done is I know, right, I'm seeing interior angle. So this, if you're looking, you could see the Z. We know that they're the same, so this is 28 degrees. Right, I also know that this one here and this angle here would be equal because they are my base angles of my triangle. They're not telling you to put the reasoning, so you don't need to remember the reasoning, you just need to remember the working, which would be, let's call this A, let's call these two things A, so 2A plus 28 is going to give you 180, so 2A is going to be 180 minus 28, so 2A is going to be 180 minus 28 is 152. So we know that 2A is going to be 152 divided by 2, which is 76, I believe. Yeah. So this angle here is 76. Now, are we seeing that x? If are we seeing a line here and a line going here? This is L, this is angle x, and then we have this entire angle, which is 28 plus 76. You guys seeing that? Which is 104. Now, what do we know about vertically opposite angles, guys? Anybody remember the rule about vertically opposite angles? Vertically opposite angles are equal. That is, if you have a line and there's a transverse line and it forms that x, we know that this angle here and this angle here was going to be equal, and this angle here and this angle here is going to be equal. So this x is going to be, so angle x is vertically opposite 28 plus 76. Therefore, x is equals to 104. Why? Because vertically opposite angles are equal to each other. Do we understand this so far, guys? Anybody's confused? And that is it for this question right here. Right, let's do the last bit, which is describe fully the single transformation. Anybody could tell me what type of transformation is this? First off, there are four types of transformation. Is this a slide? Anybody could tell me if this is a slide? No, this is not a slide, meaning it either goes up or down or left or right. This is not occurring. Is this a reflection? No, I don't think so. No, this is not a reflection. Is this a enlargement or dilation? No. E and T did not, Q and T, sorry, did not get bigger or smaller, right? If you compare the two. So we know that the single transformation, right? So this here, we saw that is a rotation because we checked to see if this rotated clockwise. This little, actually this here, if the, because it's T that is rotating, because they say what maps on T onto Q. If this rotated, this straight path would have been pointing to this direction, and if it is rotating to the other direction, again, this would be here, and then this part here would also line up here if it is rotating. So we know that this is not a rotation, it's not a translation, it's not a enlargement. So the only thing that it could be is a reflection. What you're going to do to get your reflection or your mirror line, the location of your mirror line, you take 1 point and count to the corresponding point. So from here to here is 1, right? So they are 1 unit apart. So my mirror line is going to be 1 divided by 2. This is how you find it. You find the distance, you count the distance from your object to your image, 1 part, and then you divide it by 2, right? This would tell you the location of your mirror line. So if it is 1 unit apart, that means that your mirror line is half of that 1 unit, right? So if you count this, 1, 2, right? It's 2 units apart. 2 divided by 1, sorry, 2 divided by 2 is 1. So from here, you're going to count 1 unit. From here to here is 1. Right, the same thing here to here is 1, 1 divided by 2, so it will be located between half of this unit here. 1, 2, 3, 4, that's 4 units from this point to its corresponding image. So you know my mirror line is going to be 2 units away. How? It is the distance from my object to my image, the same point, and you divide it by 2. So it's going to be 2 distance away. 1, 1, 2. So this is how I know that my mirror line is here. Do we see that, guys? Last part says, on the diagram above, draw the shape of the image of T after it undergoes a translation of -1/6 to label them image M. So shape T, alright, let's just go up. Shape T is undergoing a translation of this. So we know that, again, your values on top is your displacement along your x-axis, and your values at the bottom is your displacement along your y-axis. So what you're going to do, I'm going to show you guys how to do it on your graph, and then I'll show you how to do it mathematically. -1/6. Right? So -1 means it is going backwards. Right? So I'm going to use my red. So this one here is going 1 place back, and this is going 1 place back. This here is going 1 place back, and this is going 1 place back. This is going to be a displacement along my x-axis, and then, actually no, sorry, let's not do all the x's first. You're going to go displace 1 unit back along your x-axis and 6 units up. 1, 2, 3, 4, 5, 6. So it's going to be here. Same thing for this one. 1, and then 1, 2, 3, 4, 5, 6. So it's going to be here. And we know it's upwards because it's positive 6, right? This is 1 unit back, and then 1, 2, 3, 4, 5, 6. 1 unit back, 1, 2, 3, 4, 5, 6. So this is my location. So I did it for each point and I got the same image. This would be image M. Image M. Do we understand that? No. And next way you could have done that is find the coordinates for T. This is x is 5, 5, 3. This is 5, 3. This is 5, 1. This is 2, 1. And this is 4, 3. What you're going to do is change this to a column vector. So it is going to be, it's your object plus your translation would give you your image. So it is going to be 5, 3 plus negative 1, 6. 5 minus 1 is 4. 3 plus 6 is 9. So the image of this coordinate here would be 4, 9. And if you guys look up here, this is 4, 9. Alright? Then you do the same thing, 4, 3. 4 on top, 3 at the bottom, plus our translation of minus 1, 6. This would be 3, 9. This here is 3, 9. The next one here is going to be 2, 1. 2, 1 plus minus 1, 6 would be 1 on top, 6, 7. 7 at the bottom. So it's 1, 7. So you're looking for 1, 7. This is x is 1, y is 7. Last one is 5, 1. 5 on top, y 1 at the bottom, plus negative 1, 6. This would be 4 on top, 6, 7. So 4, 7. This is 4, and in fact 7. 4, 7. So you are getting the coordinates if you use this method where you take your coordinates for your object, change it to a column vector, which is the x value on top, y value at the bottom, add it to the translation that they give you. That would tell you the location for your image for each 1, 7. That would give you your coordinates for each of them. And that would be the end of May, June 2024. Let's see if we can hurry this up. I am going to try to do this a little bit faster. So they said, why they bring a triangle ABC, AC is 8, BC is 5. Using your ruler and compass only, construct a triangle ABC. The line AB has been drawn for you. AC is 8. So we are going, right. What you're going to do is first from A, you are going to take your ruler, put your ruler like this, take your compass, and measure out 8 centimeters. Open it out 8 centimeters. Right? And then from A, you're going to make an arc that is 8 centimeters. So you're going to draw A, and you're going to draw an arc. So we know that C is located somewhere along that arc. They said BC is 5. So same thing, you're going to take your ruler, and you're going to measure out 5 centimeters. Meaning I'm going to open it out 5 centimeters. Can I not make it 5 centimeters? Hold on. 1 second. Okay. Ah, okay. Let's just say that is 5, right? Because my thing can't go till 5. And I'm going to draw an arc right here. So I know that C is located along this line, and C is also located along this first arc that is drawn from A. Hold on, no. I'm taking it and putting it at B, and I'm drawing an arc. Alright, so again, my arc is located somewhere here. Sorry, not my arc. My C point is located somewhere here, and my C point is also located somewhere there. So I'm going to join A and connect it where C is supposed to be. Right, and then I'm going to label it as C. C. So I know that C is located here. Do we understand how to do this? Then they say measure and state the value of angle BAC. So angle A. I'm going to use my protractor. And I'm assuming this is 30 degrees, okay? Reason being is because this one was a little bit off, but it would have been 30 degrees. So you use your now you're going to use your protractor, right? Measure and state. The only way that you can measure your value of your angle is using your a protractor. So BAC is equals to 30 degrees, and that would be your answer for this. Let's look at this question here. The diagram below shows a quadrilateral triangle FGH, whose base is 13 and its h is its height. Calculate the value of each. Now, we know that if it's an equilateral, all sides are equal, so we know that this side is also 13. We know that this intersected at 90 degrees. It's a perpendicular bisector, so the length from here to here would have been 13 divided by 2, which is 6.5. Yeah? So h, we use Pythagoras theorem. So we know that hypotenuse squared is equal to your height squared plus, I don't know what to call this. Let's call it, I can't call it common h. Let's call it 6.5 squared, right? So it would be 13 squared is equals to 8 squared plus 6.5 squared. So h squared is going to be 13 squared minus 6.5 squared, and h is going to be square root of open bracket 13 squared minus 6.5 squared close bracket. Alright, that exactly how I have it is what you're going to put in your bracket in your calculator. The square root of open bracket 13 squared minus 6.5 squared close bracket, and you're going to get an answer of 11.125833. Let's just go down. So h is equals to 11.2583325, which is 11.3 centimeters to 1 decimal place. That is what h is equals to. And that is your answer for this question. Okay, so let's read this question and see what we could think about. The diagram below shows three triangles, P, Q, and R. Triangle Q and R are images of P after it undergoes a double triangle. Triangle Q and R are images of triangle P after it undergoes a double transformation. So it went from, I believe it's P to R and then R to Q. Describe fully the single transformation that maps triangle, let's go and see, P onto R. Now, they have the same orientation, so immediately it's not a rotation, it's not an enlargement, it's not a reflection. So I would say this is a slide. So what you do is to describe a slide or a translation. To describe a translation, you have to put the displacement of your x-axis and your displacement of your y-axis. Alright? So what you're going to do is you are going to look at the two corresponding points. We have a point here and we have a point here. So we're going, it's 1, 2, and it's going in a positive direction, so it's positive 2 units along the x-axis, and then we're going up, so it's again a positive 1, 2, 3, 4. So how would I describe this? 2. So I would say object P was translated to produce image R. You could put 2 and then was it 4 units upwards? I believe it was 4 units upwards. 1, 2, 1, 2, 3, 4, right? Or you can actually say 2 units along the x-axis and 4 units along the y-axis. And that is how you would do this question. Guys, 1 second. Then we want to know how you would translate R onto Q. R onto Q. Now, this here is clearly R was inverted. And anytime you see that is inverted, that means there was a mirror line. Now, to locate, to describe a reflection, the first thing you need to know is location of your mirror line. And to locate your mirror line, you take one point and count the distance from that point to its corresponding image. So 1, 2, 3, 4. So it's 4 units from R to Q, right? And then we know that from R to Q is 4 units. The mirror line is going to be 4 divided by 2, which is 2 units. So the mirror line is going to be located 2 units away from your object as well as your image. So 1, 2, so your mirror line is going to be located right here. Sorry, right here. Let's put it in blue. Right here. Right, and that would be your location of your mirror line, which is x is equal to 1. Because that's where the line intersecting your x-axis, right? Y is equal to 0 in that line, but x is equal to 1. So if I had to describe this, I would say that R was reflected along the line x is equals to 1 to produce image Q. Do we understand this? Let's look at this question here. The diagram below shows a semicircle ACB, AC, and B is a point on the circumference. Now, immediately, What angle would this be, guys? Anybody could tell me? If it is opposite a diameter within a circle, this is one of the rules with circle theorem. Anybody could tell me what angle would this be? Very good. Because it is opposite. I mean, it's not necessary to, I don't think it's necessary in this question, but it's just good to know. Right? It's a 90 degrees. State the geometrical name of AB. Now, AB is going from one side of the circle to the other, right? Or one side of a circle to the other without going through the center. So this is known as a chord. Yeah? Find the value of the radius of the circle. So, if this is an isosceles triangle, we know that the base angles would be equal. If this is 90, this would be 45, and this is 45. Everyone agrees? Alright, then we draw a line. I'm going to draw a line here. Right, that would be from B to the center of your circle. This is 90 degrees. So when they want the value of the radius, that is basically they're telling you, I want you to find my what? What is this line? From here to here is my what? My radius. But if it is a 90 degrees triangle, what will it be, guys? Is it my hypotenuse, my opposite, my what? This would be my adjacent. So my adjacent is my radius. Everyone understands how I know that this is my adjacent. It is the side that has the angle as well as the 90 degrees, right? My hypotenuse is 8.2, and also we know theta is 45, right? So it will not be signed because that needs opposite. Ka, adjacent and hypotenuse, yes. Alright, so it'll be cos 45 is equal to adjacent, or my radius, over 8.2. Carry this across. So my radius is going to be 8.2 times cos, or multiply by cos 45, which is equal to 5.7982755605, which is 5.8 centimeters to one decimal place. Do we understand this, guys? Alright, let's go to the next question. Each interior angle of a regular polygon is 160. Calculate the number of sides of that polygon. We know that the sum of interior angles is equals to n minus 2, or 180 by n minus 2, or n minus 2 by 180, right? We also know that n is equals to the number of angles. Yeah? We also know that n multiplied by 160 would give me my sum of interior angles. Because again, if it is a regular polygon, that means all angles are equal. So you're going to put n minus 2 by 180 is equals to n multiplied by 160. Alright? So this would be 180n minus, that's 360, is equals to 160n. Right? Carry this across. That's 180n minus 160n is equal, carry this across, equals to positive 360. Alright, so that would be 20n is 360. So n would be 360 divided by 20, which is equal to 360 divided by 20 is equals to 18. Equals to 18. And that would be your answer for this question. Do we understand this, guys? Anybody is confused about this? Right, let's do C. Now, if you look at C, let's just zoom in because, oh, shoot. Stop. Let's zoom in. Right. They said the diagram below shows a trapezium A drawn on the square grid. Reflection on the line L is -1, label it as image A, and a translation of 4. So image A is undergoing 1 this, and then it undergoes a next translation. It undergoes a translation of +4 and then -7. So first off, let's locate where x is equals to -1. X is equals to -1. This is the line. And if we recall, the distance from your line, your mirror line, to a point on your object is equal to the same distance from your mirror line to your image. So if I know this coordinate is, this point is 2 points away from my mirror line, I know in my object is going to also be 2 units. This one is 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It's going to be right here. And this would be my first image, A1. Right? And then they're saying that this undergoes, not this one, but A is undergoing 4 and then -7. So what we're going to do is take a point and use it. If it is 4 units positive, so that is along the x-axis, 1, 2, 3, 4, and then 7 units down, because it's -7. 1, 2, 3, 4, 5, 6, 7. So it's going to be right here. Take this one, 1, 2, 3, 4, then 7 units down, 1, 2, 3, 4, 5, 6, 7. That's right here. This one, 1, 2, 3, 4. Right, so I did the 2 first. Let's do this one. It is, let's just make sure, 4 units to the right, or 4 units along your x-axis. 1, 2, 3, 4, and then we're going 7 units down. 1, 2, 3, 4, 5, 6, 7. Shucks, 6, and then this was 7. Did I count that correct? 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 6, 7. That's what I want to know. It's supposed to be here. And then this one, well, we know it's here. So we know this is going to be your answer right here. Or you could have done it the next way is you take the coordinates of your object and then add it to your translation, and that would give you your image. Right? This would have been A, second A. Do we understand this, guys? This is January 2023. The following diagram shows 3 quadrilaterals, meaning 3 four-sided shapes, P, Q, and R on a square grid. Q and R are images of P after it underwent two different transformations. Right? Now, P is your image, your object, sorry. If I had to go from P to Q, what type of transformation would that be, guys? Anybody could tell me? There are four different transformations that CXC brings. They give you, is this a reflection? P to Q is a reflection? No. Is it a, very good, it's an enlargement. So if I'm going to P to Q, it is an enlargement. So it is getting bigger, right? So we know, I will just jot it down because I don't even know what the question is going to ask. I'm just going to write P to Q is enlargement. Right? And then P to R, what type of transformation do you guys think that is? This one is definitely not a reflection, it's not an enlargement or dilation. So it's either a rotation or it's not a reflection. So the only one that it's not a reflection, it's not a translation, it's not an enlargement. So the only one that it could be is P to R is a rotation. Are we good so far? Okay, so let's go on to the next question. Not next question. Let's go on to the next part because all they did was just show us this diagram, right? They said, let's zoom up. On the grid on page 9, draw the image of quadrilateral P after a translation of 10 minus 4 and label it image P and a reflection y is equals to 0, label that P2. So we're going to do these two first and then we'll do, so translation by the vector positive 10, negative 4. So let's go positive 10, negative 4. So you're going to take a point and we go in positive 10, which means it's going on the 10 units in the positive direction of your x-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is this here. Let's make that red. Did I do that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's here. Then this one here, I know that it's 1 unit away. This is this one on top here, and this one is this one on top here. This image here is going to be P1, they call it, or P with the one right. So this would be P with that. Then we have, what is the next one? Oh shucks, no, sorry. We only went 10 units along the x-axis. So, my bad. We're supposed to go negative 4 units along the y-axis. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then negative 4 meaning going onwards. 1, 2, 3, 4. So it's going to be here. Right, then it's going to be here, here, and then here. This is where it is going to be located. Are we good so far, guys? Now, please don't do that fasting that I just now did. Always check each of your points to make sure, okay, that all of them went 10 units towards in your displacement along your x-axis and negative 4 units along your y-axis, which is the displacement along your y-axis, right? And this will be known as P1. Alright? Then they told you that what was the next one? Y is equals to 0. Y is equals to 0 on your x-axis, and it's going, so I am going to draw that with my blue. That is this right here. Oh my gosh. With my blue line. And I'm going to count how many units. Remember, this is my mirror line. Yeah? This is my mirror line. So I'm going to go 1, 2, 3, 4. So it's 1, 2, 3, 4. 1, 2, 3. Right. And then here. Here. Again, you can check it. I just am using the shape of my image to find out if once I know one point, I use the shape of my image to draw the others, right? Right? And that is how image P2 is going to look. Right? Now let's look at describe fully the single transformation that maps P onto Q. Now, we know that that is an enlargement. Now, to describe an enlargement, right, we need to know your center of enlargement. That is the point at which it enlarges. Then we need to know your key, which is your scale factor. And your scale factor is your image over your object. Right? So if I look at this, I am looking at the height of Q. 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is 3. It is 9 divided by 3. Oh, zoom in. This would be K is 9 divided by 3. So I see that it is, the scale factor is 9 divided by 3, which is K is equals to 3. So it's 3 times as big as my object. Okay, and now my center of enlargement, pay attention to this, guys. You are going to connect all the points, the image, and the corresponding point. So this point here corresponds here. Right, then take this one, correspond with that. Yeah, this one here. Then this one here. Now, if you get more than 3 lines intersecting, you can get your point. But I'm just doing it just so that we can all see. You take all your points and extend it, and where they all intersect would be my center of enlargement, which is x is -10, y is 7. So my center of enlargement is -10, 7. Do we get that, guys? Right, so now when you are describing this, you would have to say that, now you don't have to put it exactly like me, just make sure that you have all these details. That quadrilateral P maps onto quad Q by an enlargement with a scale factor of 3 and a center of enlargement of -10, 7. That's it. Your 3 marks, saying it's an enlargement, saying your scale factor, and then saying the center of enlargement. That's where you get your 3 marks. Right? Then they want to know from object P to, so P to, okay, so this one, I should do this one first. This one here is a rotation. Now, to describe a rotation, there are a few things that you need to to know, right? For rotation, one second. Rotation, you need to know, one, your center of rotation, two, the angle or the degree it rotated, A-N-G-L-E, angle of rotation, and then three, the direction of rotation. Direction meaning if it is clockwise or anti-clockwise direction. Okay, now the hardest part in this question, guys, is to find your center of rotation. Well, let's go ahead and do it. Step one, take your ruler and join two corresponding lines. I am going to do, hold on, I'm going to do the top and bottom because I can't really, this one here and then this one here, right? That's the first thing. Join, or you could do one line, find the perpendicular bisector of that line, and then do the same thing with the next line. You're going to find the perpendicular bisector of this line, which I have taught you guys how to do. You take your your compass. You just need to make sure it is more than half the line, not more, not, it shouldn't be the total line, right? So let us just make this a little bit smaller, right? And you're going to draw an arc both on top and below, right? An arc on top, right? And then an arc below, right? And then you do the same thing with this point here, the next end. Remember, make sure to not make sure to not, what you call this thing? Make sure to not open it up. Change the difference of the length, right? That's here. Oh, shucks. Okay, this one I might need to make a little bit longer. This arc here. Right. And it's fine if you want to draw a huge arc, because you're not really sure where it's intersecting. So it's going to intersect right there. Right, so now you have where the two intersections, that you're going to draw that first line here. This is your perpendicular bisector of that first line. Then you're going to do the same thing here. I'm going to do it in a different color, green, just so that we can see the difference. You're going to find the perpendicular bisector of this line. Again, just make sure it's more than half the line. This is more than the line, so I'm going to draw it, make it a little bit smaller. I'm going to draw an arc here. I'm going to draw an arc, a huge arc, because honestly, it is oh, and one below. Right, then you do the one on top here. And then I need to one second there, guys. I'll need to do over that. So you take your pointy part, you draw an arc. One here, and then um, one on the next side. And you do the same thing with this one here. It intersects here. And then if you keep on going, hold on, it have to intersect somewhere here. I will, right? This green line. I'll need to draw an arc right there. Now, you see where those two green lines intersect? You're going to draw a perpendicular bisector of that line. Now, where those two, that black line, the first perpendicular bisector and the second I know it looks a little bit scrappy, but where those two perpendicular bisectors intersect, that is this point here, that's 4, -4, 2. Everyone seeing that? Right? So that, I know it's a little bit scrappy, but yeah, -4. So my center of rotation is -4, 2. Right? I'm just going to put that -4, 2. Right? Then we are going to connect one coordinate with the next one. Let's just zoom in. Right? One line with the center of rotation. Let's do that in red so you guys could see. I could probably use this one, you know. This line here with the center of rotation and the corresponding line, which is this line here with the center of rotation. Right? This is going to show me the angle it rotated. So first off, this rotated in an anti-clockwise direction because it is going in this direction here. Hold on, I need my pen. It's going in an anti-clockwise direction. That's this direction. So you know it's an anti-clockwise. Then you take your protractor. Let's make this a little bit smaller and I'll zoom in so we can see. We're going to line, oh, that's twisting. Right, I'm going to take my protractor and line it up with the center here. And then let's rotate, rotate, rotate. I believe that's supposed to be 90 degrees. Yep. So if let's go to the next page. My angle is 90 degrees and the direction is an anti-clockwise direction. 90 degrees and anti-clockwise. The only one that does not matter if it's clockwise or anti-clockwise is that is if it rotated 180. It doesn't matter whether it rotates clockwise or anti-clockwise. Both of them would still get 180. It would still be 180 and the image would still look the same. Right? So this one, you will have to say, let's zoom in. Or you could probably just list these things down and just write it down as center of rotation. So you would say image, not image, not image, sorry, object. Right, object P underwent a rotation of 90 degrees in a anti-clockwise direction, right, with a center of rotation of -4, 2 to produce what? Image R. And that is how you would describe this. Right? Or if you want, you could just say that the to describe it, type of transformation, rotation, and then list out center of rotation, write this down, angle 90 degrees, direction, anti-clockwise direction. If you're not, if you don't like to put it in a sentence like this, but you do need to make sure that you have everything listed down for rotation as well as center as well as enlargement. Alright? If you are not good with making up the sentence, you can just say object P to image R was a rotation. The center of rotation was -4,2. Angle of rotation was 90 degrees. Direction of rotation was in an anti-clockwise direction. Doesn't matter. Right? And that was January 2023. So we're going to skip a few years and then we're going to look at this one, which is a little bit different. January 2021, the diagram below shows two pentagons, P and Q, drawn on a grid made up from squares. State the correct word for the following list to complete the statement below. Pentagon P is something to pentagon Q. Is it a reflection? No. Is it a translation? No. Is it opposite? No. Just through a process of elimination, it will have to be congruent. Right? Give a reason why the give a reason for your choice in A part 1. Talk about congruent, the corresponding angles and sides are equal in length. So if they have the same angles and the same length in sides, the corresponding sides are equal. Therefore, that is why we say it is congruent. So the sides and length are equal. I should say the corresponding sides. The corresponding sides and length are equal. That's all you need to see, right? Sides, length, and angles. I should just now. Let's erase that and put it properly. We will say the corresponding sides, angles, and length are equal. I'm going to make this a little bit longer. Right, so the corresponding sides, angles, and lengths are equal, so therefore that is what they mean by corresponding. Right? No, C-O-R-R, spelled correctly. Okay, it looks weird. But yeah, do we understand what concurrent means, guys? Right, let's look at this one. This one was a little bit different, so I want to make sure that we understand. So let's zoom in. The diagram below, not drawn to scale, shows a pentagon. The VWXYZ in the pentagon. YZ is parallel to this. So we have two parallel lines, and YX is parallel to VW. Angles XYZ, XYZ is 114, while angle VZY is 90. Determine the values of. Now, immediately they said determine the value of this. Now, if we look at it, that's two corresponding lines. No, hear me, two corresponding. That's two parallel lines with a transverse line. What do we know about this, guys? These two angles are what? It starts with S. They are supplementary. So 114 plus WXY is 180. So WXY is 180 minus 114, which is equals to 66. And that is the answer for this one. Then they ask you, after I finish this, guys, we'll finish. Angle ZVW. ZVW, that is this angle here. Now, if I know that this is 66, I also know that this angle here, because these two are corresponding sides, sorry, These two are parallel lines with a transverse line, so this would be 114. This is a 1, 2, 3, 4, 5-sided shape. We know that the sum of interior angles for a 5-sided shape would be 180 by 5 minus 2, which is 180 by 3, which is 7. Is that 180 multiplied by 3 is 540. So we know that ZVW plus 98 plus 66 plus 114 plus the next 114 would give you 540. Right? What I did is I added up. I know this is 66, this is 114, this is 114, this is 98. So I want to find this last angle. So I am going to add this all up. Right? I'm going to get ZVW is equals to 540. Subtract. When I add this all up, I'm going to get 392. 392, which is equals to 148 degrees. And that is how I'm going to get that angle. Do we understand this, guys? This one is the one that I really want to focus on. So let us, after we finish with this, we're done for today. Right? Zoom, zoom, zoom. On the diagram, accurately each of the following transformation. The letter enlargement A by a scale factor of 2 with a center 6, 6. So what we do, let me make sure I'm saying this correctly. To do this question, you take the coordinates and multiply it by 2. So this is 4, 4. Hold on, no. Enlargement. Pause this way. So what you're going to do is you are going to remember, what do we know? That if you have your center, you are going to draw, let's make this a little bit thinner, these lines to each coordinate. We have this one here, right? Then your center to this side here. 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 Right? Now, we know that the distance from this line to this line is 1, and we're looking for something that has, because it's a scale factor of 2, we're looking for something that has, it's 2 units apart, right? From this line here to this line here. And if we look at it, we will see that from here hold on. So we know that it will be here. 1 second. Let's start with a straight line because that's going to be easy. Actually, no, that might be hard. We know that this is 1, 2, so it's 4 units apart. So from here, this line and anything on this line to this line is 4 units. So we have 1, 2, 3, 1. Right, the next one, let's make this bigger and red. Right, then the next one would be along the line, right? That's this line here, so that's from here, here to, is it here, right? And then we have this line here, which is from here to It should be this line here. Oh, that's the reason why this one was off. That's why I want to know what was going on. This line here, guys, was off. It has to start from the center. From the center, touching that point. Right. Right, so that is what you would do. You would count the straight line. So we know this is 2 units, so you're counting 2 by 2 is 4. Something that's 4 units apart. That's 1, 2, 3, 4. And then you would go back up. Right? Let me go back up. Then you would work back up to see an image. So you know this is 2 units. This is 4 units apart. Right? And then you would say from this line to this line here was 1 unit. So from this line, we're going to count 2 units apart. So 1, 2. So that's why it's here. Same thing with this. And it has to be on this line, right? So when you're doing a question for enlargement, right, and they give you a center of enlargement and they give you an image, you are going to, let's zoom in, we are going to draw a line from your center of enlargement to your object, and you're going to extend that line because we don't know how long it is, so we're going to just extend it. Then you're going to do the same thing for each coordinate. Right, this one here, let's just go down. Right, then this one here is still here, and you're looking for in your object what is the easiest unit to multiply. The easiest one would be a straight line, and it's 4 units apart. Well, 2 units apart. So from this line, 1, 2, and if it's an enlargement of 2, that's 2 by 2 is 4. So you're looking from this line here, and it has to be 4 units away. So 1, 2, 1, 2, 3, 4. So I know that it intersects here. Let's do it in blue. It intersects here. Oh my gosh. 1 second, my pen. It intersects here and it intersects here. That would be the corresponding for these 2 points. Then we go up from here to here is 1 unit. So I know how many units do I have to count? 2 units. So my straight line is going to be located on my x-axis. Right? So it will be here and here, I believe. Yeah. Then we count up. That's 1 unit up. Right? Sorry, no, I did a mistake on that E. I know it's 2 units up. Right? So it is here and then here. Then 1 unit up. So this is 1 unit up from your line that is going across here. It's 1 unit up, but we're counting 2 units. 1, 2. So it's going to be 1, 2, and that would be on that line that's corresponding to here. And that is how you would find your enlargement. There is a other way, however, I think that everyone is tired, so I'm not going to go into that, right? So this would be your E. That's your enlargement, right? And if you look at it, it is 2 times the height, the size of this object, right? Then they want this A is using a vector t of -3, 2. So we know that if it's going -3 along your x-axis, that's 1, 2, 3, and then how many units along your y? 2. 1, 2, 3, and then you're going 2 units up. 1, 2. So it's going to be here, right? going to be here. You do the same thing for each point. Well, actually, no. You could count from here. So this would be 1, 2. It was 3 units up and 3 units this side. So let me just put that negative 3, 2. So 1, 2, 3, and 2 units up 1, 2. So it's here. This one, 1, 2, 3, and 2 units up 1, 2. That's here. So I know my A is going to be here, here, and then I know this is how the A is going to look. And this would be after the translation of negative 3, 2. And that is the end of January 2021. So we will end here today.